Hello everyone, today we are covering lesson 1.3 from Precalculus, which is rates of change in linear and quadratic functions. So to start things off, let's look at some vocab. We're going to start off with what is a secant line. So a secant line is a line that is formed from 2 points on a defined function. So function, as long as we have it defined in some sort of way, it could be numerically, analytically, graphically. If we use 2 points on that function, the average rate of change between those 2 points is equal to the secant line formed from those 2 points, or the slope of the secant line between those 2 points. So we've got a formal definition here and a little bit of a visual representation. The one thing I'm going to add is this point-slope form here on the right. You're probably used to y equals mx plus b as like the de facto way to describe a line slope-intercept form, where m is the slope and b is the y-intercept. Point-slope form is just a different form to represent a line where you can use any point instead of just the y-intercept and the slope to define a line. We won't go too far into that, but it is a form of a line that we were going to use quite often in calculus. Alright, so let's find the average rate of change for the following linear functions. So all of these functions are linear, they are all lines when graphed, and I have the graphs of them right here for us. So one thing I'm going to do though is I'm going to ignore the fact that I did draw the lines here for us already, and I'm going to pick some x values based off of the equations themselves and kind of what they lend themselves to. So the first one is a little bit weird because we have a fraction as our slope. So if we notice, the fraction has a denominator of 3, so the x values I'm going to use for my 2 points are going to be divisible by 3 to make my life a little bit easier. So if I plug in a 0, well, 0 times 2/3 is also 0, so 0, 0 is a point, and we can see that graphically right here. And then the next point I'm going to use is going to have an x value divisible by 3, so I'm going to choose 3 to make life easy on myself. So 3, and if I plug in 3 times 2 is 6, divided by 3 is 2, so 3, 2 would be a point, and again we can see that graphically here. To find the average rate of change, we would take the difference in the outputs, divide that by the difference in the inputs, so 2 take away 0 over 3 take away 0, well that's just equal to 2/3, which just so happens to be the slope of the line defined analytically. So we can do something similar with the next function. I always like picking the 0 as the x because it makes life easy. If I plug in a 0, I will get positive 3 as an output. And the next point, we can pick just 1 because there's no fraction here. 1 times negative 2 is negative 2 plus 3 would be 1. If we find the rate of change between those points, we get negative 2 over 1, or just negative 2. Which is the slope of the line defined analytically, which is really, really nice. Last one's a little bit weird. There's no x, so when we pick our x values, like 0 and 1, there's nowhere for us to plug it in or substitute into the function analytically. But all of the y values are negative 3, so we're just going to make our y value negative 3, our output negative 3. And if we find the average rate of change here, we would do negative 3 minus negative 3. Over 1 minus 0, and that gives us 0 over 1, which is 0. So the line is constant, it's horizontal, it's flat, it has an average rate of change of 0. So if you notice, there's a big idea here. The average rate of change for linear functions is constant. It's just a number, and that number just so happens to be the slope of that linear function. So now we're tasked with finding the rate of change of the average rate of change for each of these linear functions. So what's different about this is that we need to find 2 rates of change, 2 average rates of change, and then find the change between them. So instead of needing 2 points for this, we're going to need 3. So what we're going to do is we're going to use the 2 points we used last time, which was 0, 0, and 3, 2, but we need another point. And we have to be careful when we're picking our third point here because we want the spacing between the points in terms of its inputs to be the same. So since there's a difference of 3 between the inputs here, we want another difference of 3, which would be 6. If I plug in 6, I will get a 4. And we're going to find the average rates of change between the first 2 points and then the second 2 points here. So we'll do the same thing we did before, which would be 2 take away 0 over 3 take away 0. which gives us 2/3. Then we're going to do 4 take away 2 over 6 take away 3. That also gets us 2/3. Now we're going to use those two numbers as our new numerators. So we're going to do 2/3 take away 2/3. The difference here is the spacing of our intervals is now going to be our new corresponding x value, or the change in x. So since the interval difference between our points was 3, we're going to make the denominator 3. So 2/3 take away 2/3 would be 0 over 3, which is just 0. So there's no change in the average rates of change for this function, which kind of makes sense if you think about it. Let's move on and try these out. If you want to pause and try them out before me and see if you can beat me and get the same answer, that would be awesome. But what I'm going to do is I'm going to pick points that I used last time, which would be 0, 3, and then 1, 1. Then I can pick a third point, which would be 2, negative, not negative 2, negative 1. And then find those average rates of change. So 1 minus 3 over 1 minus 0 gives us negative 2 over 1, which is negative 2. So that's the first pair. Second pair would be negative 1 take away 1 over 2 minus 1, which would be negative 2 over 1 again, which would be negative 2. And I think we can already figure out what's going to happen here. We're going to have a negative 2 take away a negative 2. In this case, the difference between our x values was 1, so we're going to put a 1 in the denominator. We still get a 0 over 1, so we're going to get a 0 again in terms of a solution to this. A little bit weird. Now this one, we found the average rate of change to be 0, but we can do that again. We can do 0, negative 3. We can do 1, negative 3, and our next point would then have to be 2, negative 3. So negative 3 take away negative 3 over 1 minus 0 gives us 0. Negative 3 take away negative 3 over 2 minus 1 would also give us 0. 0 minus 0 over 1 is 0. So what do you notice about all of these equations, all of these answers? The average rate of change for the rates of change of linear functions is 0. That's a little bit weird. But it kind of makes sense because the average rate of change is constant. So the change in a constant is nothing. There's no change. That's why we call it a constant. So linear functions are relatively straightforward. So we have this big idea that their average rate of change is constant, and their change in their average rate of change is 0. Let's look at quadratics and see how those differ. So we got this lovely quadratic equation here, x squared minus 2x. And I've given us a nice graph so we can use it as a reference for some of them, make life a little bit easier for us. We've got points at every whole number to 6, so 1, 2, 3, 4, and then we go off the rails and we kind of can't see it anymore. But we can use the information we have to make life a little bit easier for us. If I see here, the point is 1, negative 1, and 2, 0, so 1, negative 1, and then 2, 0. So the average rate of change between them would be 0 take away negative 1 over 2 minus 1, which would be 1. Straightforward. The line I could draw between those 2 points would have a slope of 1. But look how 2 to 3 is steeper. Let's see how that changes. Our point here would be 2, 0, and then 3, 3, it looks like. Yeah, that's what it looks like to me. So we'll do 3 take away 0 over 3 take away 2, and that gives us 3 over 1, which is 3. So it's getting steeper as time goes on. Its slope went from a 1 to a 3. It went steeper. Let's check out 3 to 4. That one looks even steeper. We went from this line here to this line here to this line here. It's getting steeper as we go, so we can expect to have a larger number from this. And this point here looks to be 4, 8. So we have 3, 3, and then 4, 8. So we have 8 take away 3 over 4 take away 3. and that gives us 5 over 1, which is 5. So our slope is indeed steeper, it's increasing. So it went from 1 to 3 to 5, so hopefully we can have an estimate or a hypothesis of what we might think the next ones are. But I want you to go ahead and pause the video and try them out. If you're not sure of how to get the y values, they did define the function analytically for us, so we can use that to help us get some answers. So at x equals 4, y is equal to 4 squared, take away 2 times 4, which is equal to 16, take away 8, which is equal to 8, which is what we got last time. At x equals 5, we'd have y is equal to 5 squared, take away 2 times 5, that would be 25, take away 10, 15, and we'll use those points for our average rate of change. 15 take away 8 over 5 take away 4, that would be 7 over 1, which is 7. Was that what you predicted? Let's try one more time and see if we can establish that pattern. So we've already found 5, so I'm just going to do, we have 5 comma 15, so at x equals 6, y is equal to 6 squared, take away 2 times 6, that would be 36, take away 12, that would be 24. So we're going to have 24 take away 15 over 6 take away 5, and that should be 9 over 1, which is 9. So we went from 1 to 3 to 5 to 7 to 9. Well, the rate of change of the average rates of change for quadratic functions is consistent, is a constant. So if we look here, what would that constant be? Well, it increased by 2, increased by 2, increased by 2, increased by 2. For this quadratic function, the rate of change of the average rate of change would be 2. So the average rates of change are increasing. So now, if we look at this question here, they want to find the rate of change of the average rates of the following quadratic functions. So we have to be careful. We don't have to do all of these. Since we've established that the rate of change of an average rate of change of quadratic functions is constant, we need the 3 points like we did in question 2. So what we need to do is we need to find out what those points should be. I like plugging in and starting at 0 because it makes my life easier, but you can start virtually wherever you want. You should get the same answers as me. So we'll do the first one together, and then I want you to pause and try out the second one. So I'm going to say at x equals 0, y is equal to negative 2 times 0 squared plus 10, which is just 10. At x equals 1, y is equal to negative 2 times 1 squared plus 10, and that would be 8. At x equals 2, y is equal to negative 2 times 2 squared minus 10. That would be 4. That would be negative 8, so that should be 2. Hey there, Editor Mr. Whaley speaking to you. At x equals 2, I put a minus 10 instead of a plus 10. Either way, I got the math right. The answer should be 2, but just in case you were wondering. So now we're going to find the average rate of change between point 1 and 2, and then point 2 and 3. So we want 8 take away 10 over 1 take away 0. That's negative 2 over 1, which is negative 2. So that's our first average rate of change. Our second average rate of change would be 2 take away 8 over 2 take away 1, which would be negative 6 over 1, which is negative 6. So what's happening here? We started with a negative 2, we ended with a negative 6. So negative 6 take away negative 2. Difference in our x values was 1. So that gives us negative 4 over 1, or just negative 4 as the rate of change of the average rates of change. So I want you to pause the video, try this one out, but I'm going to get started here. We need 3 points. I'm going to pick x equals 0 again because it's nice and easy. Y equals 3 times 0 squared. minus 2 times 0. Well, that is 0. That's nice. At x equals 1, y equals 3 times 1 squared. Take away 2 times 1. That would be 3, take away 2. That would be 1. And then at x equals 2, we're going to have a little bit more fun here. Y equals 3 times 2 squared. Take away 2 times 2. Well, 2 squared is 4 times 3 is 12. This would be 4, so it's 12 take away 4. That would be 8. All right, so our first ones would be 1 take away 0 over 1 take away 0, which would be 1. Our second one is going to be 8 take away 1 over 2 take away 1, which would be 7 over 1, which is just 7. Oh, we don't need to. Then we're going to find the rates of change between those, the average rate of change between those. So 7 take away 1 over 1 is 6. And that would be our average rate of change, or the rate of change of the average rate of change of f of x here. How did we do? Hopefully that's not too bad. The last question I have for us today is concavity. So I have a little note down here before we get started. Remember that concavity is determined by the sign of the rate of change of the average rates of change. It is how the change in the change happens. If it's positive, it's concave up. If it's negative, it's concave down. So if we look at these examples here, back in number 4, we would say that f of x here, since it has a negative rate of change of an average rate of change, it would be concave down. And for this function here, we would say it'd be concave up because the 6 here was positive. So they gave us another function here defined numerically, and it is either concave up or concave down over its entire domain. So that means the entirety of where this function exists, it's either going to be concave down or concave up, but it cannot be both. So what we're going to do is we're going to try to find what its concavity is. Is it concave up or is it concave down? To do this, we're going to do very, very similar to what we did in the last one here. We're going to find the rate of change of the average rate of change, but instead of caring about what the number is, we care about what the sign is. So we're going to pick our 3 points. I'll pick this point, and this point, because that'll make life easy for us. So we are going to do 20 take away 18 over 16 take away 15. That would be 2 over 1, which is 2. The second pairing would be 20 take away 20 over 17 take away 16. That would give us 0 over 1, which is 0. And then we want to find the average rate of change between these. So it would be 0 take away 2 over 1, which would be negative 2. Since it's negative, we would say it's concave down. So concave down. And like I said before, it's very important that we get in the habit of explaining why we're answering the way we are. So we're going to say it's concave down because the rate of change of the average rate of change for the function is negative. All right, and that is lesson 3 for us. If we have any questions, please make sure you ask in class. Otherwise, I hope to see you in the next video.